Hello, my name is Andrew Schonfeld. I'm here to take you on a journey through detail. I am the main developer on detail, and the main purpose behind detail is a way to visualize the data underneath your pandas data structures. Now, how did this tool even come to be? Well, I was working at a hedge fund in Boston about a year ago, and we were in the middle of a SAS to Python conversion. They relied heavily on SAS's proc insight function for visualizing their data sets. When switching to Python, pandas became kind of the de facto choice for our data exploration, and we needed an easy way to explore the data in a similar way to SAS's proc insight. The big hurdle in this process was giving people the illusion that they were viewing all of their data at once. That's where kind of this natural progression of having the browser display your data for you, because it's going to show you how many rows and columns you have going on, but in actuality it's only going to display however much data you can fit on the screen, and that's really efficient. There's great tools out there like React Virtualized in which our grid is built upon. But without further ado, let's kind of go through some of the features of detail. And first off, I will show you how to download detail. Detail, here we go, nice little icon. Detail is available on both CondaForge and pip. Hopefully, if you're a Python user, these topics shouldn't be foreign to you. But now, let's get down to the nitty gritty. Let's see what detail can do. First off, I'm going to show you how to fire it from a Python console. First, very simply, you import detail. You're going to set up some test data here. And boom. It's going to present you with this little URL. You click on that, and there you go. We're seeing the exact data that we just loaded. You can also kill this process, shut it down, and it's gone. You'll see in your Python console executing shutdown. That means it is gone. But most people like to work in Jupyter notebooks. So I'm going to show you how to fire it off in the same exact way from a Jupyter notebook here. Import detail, set up some test data, shift enter. Bam. The detail session is displayed right in your Jupyter cell. This is using an iframe component that Jupyter provides for us. You don't have a lot of space, but you can adjust that. There's functions to adjust that. But in most instances, you're going to view it in the browser because you have a lot more space. So as you just saw, I clicked on Open a New Tab. You get your simple grid components, sorting. We can filter this thing down. Boom, we're filtered down to one. You can clear out your filters. We can make more customized filters here. So we'll do =1 or 0 == 2. Apply, and there you go. We'll clear that out again. I'll show you here. You can edit cells. And the next feature that I want to show you is being able to build columns. So here we're going to take a column, we only have one, and we're going to do a sum, and you're going to specify a constant here. So we're going to add 5 to every value in that column 0. And there you go, temp call 5, 0 plus 5 is 5, there you go. We're going to try moving columns, move it back to where it was, and let's try creating another column that combines those two together. So we're going to do 0, we're going to do temp call. You see a little code snippet here, very nice, gives you a little information on what's going on underneath the hood. Don't forget to give it a name. And there you go, you have 3 columns now. You want to move your column to the front, boom. You want to move your column to the back, just as easy. The next thing I want to show you here is the ability to spin up multiple instances at once. Shift enter again, oop, kind of came out of view there. You're viewing your data again. Now, if we go and click open a new tab, you're going to see another option right here called instances. This has 2 instances associated with it. This is the one that we had opened previously, and you can see it shows you the column names that are available. It gives you a little preview if you want to look at it. And if you click this, we will jump right back to where we were. But we're working with our other instance, so we'll click back and view that again. The next thing that I want to show you here is, so we had created 2 new columns. Originally, we didn't have those columns before. I'm going to go and create a new column here as well. And then I'm going to jump back to my Jupyter Notebook. A lot of people want to see, oh, you know, I've been doing some cool work here. I want to get at this data. The way to get at it is I've created my detail instance, stored it in a variable. That variable has this data property. There you go. We see our temp call, which wasn't there when we called detail.show. You say you want to edit your data on the fly in your notebook and see that flow through to your detail instance, you can do the same thing. So there we go. We've just added this new call, and it's going to be all 5s. Refresh this. New call, 5s. Very easy, very easy. You want to get at the instance that we created originally, but as you can see, we didn't store it in a variable. The way to do that is, here's our original instance. You look at this value on the end. That is the number that gets associated with your piece of data. So detail.getInstance1, we're gonna, there you go. This should match what we see over there. Yes, it does. You want to shut down detail from your Jupyter Notebook? You can do detail.kill. Oh man, I was wrong there. I forgot, it's an instance level function. So detail.kill, I'm going to do that on D2. And there you go, executing shutdown. If we try to view the data with 2, it's no longer there. So behind the scenes, there's actually a Reaper that if you do not do any actions on your instance for an hour, it will clean itself up and shut down. This is just kind of a way that we will prevent people from having a ton of instances of detail just kind of crowding their machines. You can shut that functionality off very easily by, when you call detail.show, specifying the parameter Reaper on, set that to false. So very simply, there you go. This data frame is not real. But now I'm going to show you some examples of some larger scale data that we have available. So this here, I'm going to show you that you can hide columns. You'll see that information being displayed here. You want to unhide them. There you go. Another nice feature in the build columns functionality is this transform. Transform is very powerful because at my previous job at the hedge fund, we really like to mean adjust values for smoothing purposes. Click transform, say which value we want to group by. We'll group by C. We'll make our column that we want to display the groups of C, I, and we'll specify what aggregation we want to do. Once again, little code snippet here if you want to see what's going on under the hood. We'll click create, and there you go. If we sort by C, you'll see all the values where C is 0 are going to be the same. Once it switches to 1, it's going to be different because all these values is the average of I for each group in C. And if you want to say mean adjust your values in I, we'll just go back to build column. And we will choose difference of I and our transform. And there you go. These are our mean adjusted values for I grouped by C. The next thing I want to show you is cleaning up your columns. Let's, we'll show you rename first. Let's rename this. Add a 2, boom. You want to delete this? It's gone. Very, very, very powerful stuff. You want to see the actions that we just performed. I haven't shown you yet, but we have this little code export. Click that. it's going to show you everything we've been doing. Some little stuff up front, some massaging of data that we do before it hits the grid. So here we created our mean adjust column. We renamed mean adjust to mean adjust 2, and then we deleted mean adjust. Now I could use pandas delete function under the hood, but this is, I don't know, just a different way of doing it using a list comprehension in Python. And then we sorted our values on column C. So if you copied and pasted this in a Python Jupyter notebook and ran this, if you have your data frame set to what you had passed into this, it should work. The next piece of data that I'm going to show you is this large data set that I've created with a lot of just temporary fake data. We dealt with time series security data at the hedge fund. So here we go. We have some dates, we have some securities, and then we just have some random data being populated. One very powerful function that I didn't show you earlier is this describe function. This is calling pandas describe on the data frame and displaying all the output for you. So date, we're just going to see some standard statistics with it, counts, first, frequency. Now these statistics that are being displayed differ with each data type that you're looking at. So we got some dates, some integers, strings, floats. Now you switch over to string, you are going to be able to see a box plot here. You know, your 25th percentile, 75th percentile, 50th, or no, this is the max, min, 25th, 75th, and this is, you get your one little point here is the mean, and this is the median. The next thing is you can look at the histogram of the values in this. Not very interesting data, but if we click this one, which is random, you're going to see a nice little bell curve of some values here. You can switch how many bins you want to look at, switch it to 50, and there you go, it gets a little bit more diluted. Displays information about the unique values. This kind of comes in handy if you're looking at some categorical data. So here we go, these are all the different categories. It gives you the count of how many times that category shows up. Let's jump back to our random data. So these are unique, but since there's so many unique values, it's only going to display the top 100. So the way that it determines the top 100 is it checks the count and says, you know, sorts on the count. All of these only show up once because it's random. Maybe there's a chance that one shows up more than once, but in this case it's not. We'll go to outliers here. Now, there's some complex outlier detection going on under the hood. If you want to look at the code behind that, it's listed on the README for detail. You can apply the filter here that determines outliers and filters them out of your data. If you clicked this, it would go back to your instance and that filter would be displayed here. The next thing you can do is you can choose which columns you want to be visible. I've selected these three. We'll update the grid. Come back, only those three are visible. Come back here. We will go back to describe. We'll check all of these, update them, and they are all visible again. Now, we're going to look at some nice little highlighting functionality. We have heat map highlighting by column, which kind of creates the colors based off of the data for that specific column. So there's a lot more variation going on here. There's also the ability to do overall. This is where, you know, all of the columns are treated as one. So the minimum values are kind of highlighted more in red. The maximum values are highlighted in green. And these int values are way higher than everything else. So everything becomes red here. The other thing that's going on, you'll see a bunch of columns went missing very quickly. Heat map, these colors can only be determined off numeric values. So these are all the columns that contain numeric values, ints and floats. If you want to turn it off, you just click that and you're right back to where you were. We also have this nice data type highlighting. So all the different data types get different colors. Booleans get yellow, categoricals get this little purplish, time series get this like pink. Dates are once again in pink. You have time deltas in orange, strings in white, and integers in blue, floats in green. Switch over to outlier detection. Any column that contains outliers is going to get a little star in the header, and if it is an outlier, it's going to get some shading. This is one of the top values, so it's getting reddish, and one of the lowest values is getting this bluish. We'll switch over to missing. If there's any missing data in a column, the column is going to get the exclamation point, and the cell that is missing is going to get highlighted in yellow. Lastly, we have this range highlighting. So we'll choose anything that's greater than 1. You just saw things change under the hood there. So any value here, any numeric value that's greater than 1 is going to get highlighted yellow. Want to clear it, you just click the X. We also have this low variance flag. Now I accidentally closed a tab. I believe that this is it. No, that is our coronavirus data that I'm going to show you a little bit later. Here we go. So this is some housing data that was provided to me, and some of the machine learning folks out there wanted to have a quick way to show display which columns contain data that has a low variance associated with it. So these ones highlighted in red follow that principle. And if you click on the column and click this variance report, it's going to show you how it determined that this column has a low variance or not. There's 2 checks that it follows. We're also showing some information about percentage of missing values, percentage of outliers based off of that calculation I mentioned earlier. Some other helpful statistics. I've had other people in the machine learning community say that this isn't a useful statistic to show people because it can be misinterpreted. But you know, I'm here to serve. This is a free product, so if people want it, I'm gonna try and add it for them. So the next thing we're gonna do is we're gonna try and build some charts. So this is our large data set. We jump back here, you see there's over 1 million rows. Just for speed purposes, I'm going to filter down. And so what this is using under the hood is just Pandas query logic. If you click this informational button, it will bring you to the Pandas documentation for this query language. So let's just make a simple line chart, date, and we'll choose one of our random columns. So this is going to take a little while to run, and the reason why it's taking a little while to run is because we specified no aggregation. And if you remember, this was security-based data, so there's multiple values for each date. We're grouping on date here, and we're just viewing the values. So there's multiple values coming back in each one of these dates here, and it's kind of nonsensical. This is not how you want to view it. So the way you're going to make sense of it is, let's say we want to take the sum of all those values for each security at each date. So here we go. These are the sums at each one of these days. You can jump quickly between bar charts. You got scatter charts. You have a pie chart here. Now, pie charts can't display negative values. So if for some reason your data does contain negative values, it's going to be displayed up here in the top. Don't want to hide anything from you. You have word clouds here. Now, because we're taking the sums, all the data becomes so close together that the word clouds can't handle it. We'll go back to no aggregation, and it gets displayed here. The ones that are displayed the largest are the ones with the largest values. The ones that are displayed very small have the lowest values. We'll turn our aggregation back on. Actually, we'll switch to some 3D charts, heat maps here. So date, we'll make our y-axis the security ID, and our z-axis becomes our random data again. This should, actually, yeah, because of the fact now we're at the lowest combination, all of these points should be unique. So we can also change the coloring behind this heat map. And there you go. We also have 3D scatter charts. A little interesting, you can do some moving around of the data. You can zoom with your click wheel. We can also do surface charts. Same kind of thing as the 3D scatter, except it makes it look more like terrain. I move this a little bit deeper there, so there you go. The next thing that we can do is display some map level data. So we're jumping back to our housing data, which if you scroll over to the right, you're going to see latitude and longitude columns. I'm going to jump to the charts again, jump over the maps. Let's go with the scatter geographic. We'll select our latitude column, select our longitude column, and here you go. This is literally just displaying the points. But say you want to color these points based off of some value. Let's go with grade. So each one of these points is the equivalent of a home somewhere in North America or what looks like Norwegian Europe. And what's driving the coloration is the grade of the home. We can once again change the color of these points. Zoom in. And the other nice feature here is you have code exports again. So if you want to see the code that made this chart underneath the hood, this is using Plotly Dash, very powerful. You can use this and start tweaking it on your own in your notebook. Very nice. Now I'm going to show you chart animations. So this is some coronavirus data that I've loaded from the New York Times. We're going to jump over to the charts page, go back to maps. Now, if you look at the data here, there's a state code or there's a state name. You can use either. We're going to go with Choropleth, and the location mode, let's go with US states. So the 2-character code, state code, value, and let's do cases. Now we haven't specified an aggregation, so it's going to throw an exception. And it tells you, please select a different aggregation. So let's go with mean. So what this means here, what we're looking at, oh wait, don't do mean, let's do the sum. Or no, let's do the max. So the way that this data is structured is it's time series data. So the maximum is going to be the most recent day. So what we're looking at here is the current case count for all of the states and all of the United States. California is currently in the lead because it is the reddest. But say you want to animate this. There's a lot of the states have really been active recently with cases. It's not a good scene. So let's just let's filter down to anything after June 1st, and we will turn no aggregation back on, and we'll animate by the date. What this is going to do is display a chart. By default, it's going to show the data for the most recent date. I know it's going to look like you're looking at June 2nd, but if you click this play button, it will start from June 2nd and progress all the way to the most recent date, and the colors should start changing. So right off the bat, New York was in the lead by a lot. And more recently, we started relaxing restrictions. California, Texas, Florida, they started catching up very quickly. They're getting redder. And there you go, not a pretty sight. Let's try and animate a bar chart. So we're going to make our x-axis state, just so we can understand what we're looking at if people don't know state codes. And we're going to go by cases again. Right now, no aggregation doesn't make a whole, or it still saved our information about what we were animating on before, dates. So this doesn't make a lot of sense right now. Let's sort our bars by the cases. So now the ones with the most cases are at the right, the one with the least are on the left. Right now, California's up there, Florida, New York, Texas. But let's animate this. You know what, let's that took a while to display all the information. Let's go to June 15th, and we're gonna play this. Now to start off, New York was ahead of everybody. And you're slowly gonna see more states starting to catch up. There you go. So very powerful stuff. You also have the ability to export your chart to a static HTML file. So that way, if you wanted to say email this to someone and you didn't want to leave your detail instance running for days on end, you can send this to them and it's going to have all of the JavaScript included. It's going to be a little bit of a large file, but it's going to work, and it's going to work for the rest of the time until you delete that file. Very nice. You also have access to this function in Jupyter Hub as well. So I have this COVID-19 notebook, and you see this offline chart function. So we have a detail instance. We've loaded the data frame into it. We've stored it in a variable, and then in that variable, which contains the data, we call offline chart. We're going to create a bar chart where the x-axis is state, y-axis is deaths, and we're going to show the max. And we're going to do a bar, we're going to sort the bars on deaths. This is the output. This was ran way in the past, so New York was still in the lead at this point. But you also have the animation. So you saw there, I just opened this notebook. I did not run anything. These animations still work after months of sitting dormant. So this is great. If you want to like check your notebooks into a GitHub repo and have people look at them that way, you can do it that way as well. So I mean, that's most of the functionality of detail. What I want to show you very quickly is an experimental feature that I'm working on right now. Let's take the means of this. So anytime you have an aggregation, which means that there's multiple data points going into each point of this chart, I have this drill down functionality. Click a point, now you're going to see the histogram of values that went into that point. So we're looking at July 19th and all the aggregation. So the mean of these points was this value, but all the points that went into this mean are right here in this histogram format. If you want to see the bar chart of this doesn't make a whole lot of sense here because we're just showing the dates. So all the dates are the same, but if you change the column to say security ID, it might make a little bit more sense to you, because now you're going to see the security ID associated with this. So this looks like probably the biggest point. You're going to see, all right, security ID 102195 has the largest value. It's still a work in progress, but it's getting there. So sorry for the long-winded video, and I appreciate you listening. Anytime you need any enhancements to this, just go right to the GitHub page, submit any issues or requests for functionality, and I usually get back pretty quick. All right, thanks for listening. Take it easy.